like this guy. As you can tell, it is springtime in Detroit, which means it's a good time to find snakes. And snakes actually played a role in human evolution.
Humans have some of the best eyesight in the animal kingdom, and believe it or not, snakes have a lot to do with it. You experience their effects in surprising ways and more often than you think. At the dawn of human evolution, we looked a lot more like our primate cousins. Our ancestors slept during the day in trees. Unfortunately for them, that's where constricting snakes hunted. When these primates were woken up by the approaching snakes, our ancestors with the best eyesight could spot the snakes despite their camouflage and escape. The primates without sight sharp enough to detect the approaching danger did not survive, and their genes are no longer with us.
One study showed that snakes are amongst people's top phobias. And whether you like them or not, nature may have given us an early warning detection system to notice when they're in our environment.
Primates are unusual among mammals in that they have really excellent vision. And as a whole, primates have better vision than any other mammal. The argument is that the selective pressure favoring the expansion of their visual system came from snakes.
When primates stopped living in trees, snake detection was still an important part of their survival. Stepping on or near a camouflaged venomous snake was as dangerous then as it is now.
This roadside statue right here is Sam and Sarah. They're red-sided garter snakes. The statue is outside of Narcissus, Manitoba, which is the home to the largest gathering of reptiles anywhere in the world.
They have to, in the wintertime, get underneath the frost line in order to survive. And so up here in Manitoba, Canada, the winters get to about 50 degrees below zero, and they can last for 7 to 8 months. So the garter snakes are able to access these sinkholes, pits, what have you, that enable them to get under the frost line. So that's how they can survive the winter. And it's not like there are these caves or sinkholes all over the landscape. So where they occur, all the snakes for miles around will come back to that one spot, and that's how we get these incredible numbers. In the summertime, you don't see those numbers, but it's a great place to be a snake in the summertime because it's nice and warm, there's lots of water, there's frogs and fishes, lots of things for them to eat. It's the winter that's the hard part, and so that's the geology is what makes it so that these snakes can survive and really flourish here.
Ooh, they feel really cool. They're very soft.
These snakes aren't poisonous, but they give us the same programmed response as our ancestors would get from a snake that posed a threat to its life.
One of the physical characteristics that snakes had an effect on in humans is a part of our brain called the Pulvinar. Could you talk about that a little bit and tell me what it is?
The Pulvinar has expanded as part of the subcortical visual system that apparently doesn't require conscious decision making to be able to work. And so what it does is it allows us to detect dangerous objects before we're consciously aware of them as part of that visual system.
Our Pulvinar is a part of our visual system that helps us decide where to focus our attention. In the case of snakes, it bypasses our conscious brain and causes us to jump back and become more alert if we see a snake or something we misinterpret as a snake. It's better to think we see a snake and be wrong than to overlook a potential danger and possibly die or become injured as a result.
Even though we've got really great visual systems, we still miss them and we still step on them. They don't want to be seen. So selection has favored really nice camouflage with snakes. It's this arms race between their camouflaging abilities and our visual ability to detect them. And we're really actually very good at detecting them in our periphery, and when their environment is kind of cluttered, we pick them out better than we can pick out other stimuli, other objects, like control objects that people have done for experiments.
When we're out hiking and we see a squiggly stick on the trail and we jump before we know what we're looking at, or maybe we see it's a stick and we still jump.
Yeah, I mean, that's the exact thing I'm talking about. We have sort of two pathways of this visual system combined, and that's the first one is the faster, what I'm calling the detection, the non-conscious detection process, and then there's the conscious recognition system. And that's just a little bit slower. So we may jump or freeze when we see something that's kind of shaped like a snake on the pathway. And then suddenly we go, oh, sorry, no, that was just a stick. That's the path that it takes.
So the next time you're out hiking and encounter a stick on the trail and jump back before you realize it's not actually a snake, remember it's an echo of ancient programming, a balance between survival and evolution, where snakes have left a permanent mark on the way our species sees the world around us. Please like this video and subscribe to our channel, The Wild Where You Are, so you don't miss any of our new videos.